Hey Julian, let me know whether you can hear me. And audio quality is good or bad, or music's too loud or not. Or whether you like the music or not. Yeah, echo off. Hey Omi, echo should be off now. Music's cute, yeah, thanks. Wee, I know that. What time is it in Portland? Did you have to get up early? I forgot already. Oh my god. Good, yeah. Thanks, Julia. Yeah, I've got a new mic. Even newer one, like I said. You're gonna see. Alright, hey everyone, there we are again for another nice Sunday chill Super Spark event. I'm just gonna turn down the music a little bit so it's a little bit too loud for me. Yeah, I just already also put the Instagram live on. Hello Instagram. If you want to join us and do a little Spark action over on Twitch, I put the link in the pinned comment, so just come join us over Twitch because it's a little bit easier to see what's going on, I think. So yeah, I'm happy everyone's here and we can get to it. And tonight we're gonna have Lasse on the stream and that's gonna be amazing. Hey David. I'm not even gonna try to pronounce his name after I mangled Nolan's name already on the last one. And Lasse's name is like way too complicated. Hey Safta. And so yeah, I thought maybe before we get into hardcore Spark action, we might actually do a little bit of kind of like looking at what happened last week. I don't know whether that's something you guys are interested in, but I just noticed a few things I just wanted to share with you or look at maybe. And one of which is actually in the world of AR, this is obviously relevant, is that and this is just a random, you know, all of things, but like maybe you've seen it, Magic Leap didn't go out of business, but they kind of closed the consumer facing division and cut half of their jobs. So this is it, 1,000 employees laid off, and also just now it's not available for consumers anymore, I suppose, but only for enterprise clients. So I thought that's interesting because I felt that now with the Corona and stuff going on, I felt there could be like a surge in VR and in AR, but maybe not. Yeah, Julian, Spark hoodie actually, we got it from Spark directly. That was one of their events they were doing in London, and I think Noland got theirs, his t-shirt there too, right, Noland? Yeah, maybe. I mean, obviously, Noland's saying Unreal. It's obviously a chance, I think, for smaller things, smaller kind of companies to search to come up if bigger companies close down. I mean, let's hope so. Actually, I saw, hey, Nikolai, thanks for the follow. I'm just gonna adjust this guy here. Snapchat is also not doing too great, actually, I heard. So that's probably fuck off! Not great. But anyway, I hope and we will do really well. But okay, so the other thing I've noticed, that's funny too, as maybe you're seeing, I have a new webcam and a new microphone, so I upgraded for the stream because it was a lot of fun. The only drawback might be that you can see whether I'm wearing pants, but for the occasion I am wearing pants. Usually I don't. But what I noticed is that I wanted to get a new webcam, and you can't. It's like it's sold out. It's crazy. Like if you look at the good one is the Logitech C920, and if you look at shopping, so first of all, it's like crazy expensive compared to what it used to be. So now it's like $150, $120. And this used to be, because it's an older model, this used to be $20 or like, no, not 20, but like $50 or something. And now it's like $150. So it's crazy. So the webcams are the new toilet paper, I suppose, because everyone's now doing Twitch streams and other conferences on webcam and whatnot. Noland. Actually, I take one. What I'm using now is I have an old iPhone as a webcam, and I have another old Android as a webcam. Hello. And I'm noticing actually the chat is not showing up so well, but yeah, maybe we can make it a little bigger. Maybe like this. Yeah. Yeah. So those are the things in the world I noticed. Welcomes and toilet paper. Hey, Shy Mera. So hi, Mera. I don't know. Thanks for the follow. And then I thought, well, maybe we can look into what's happening in Sparkland, and so let's maybe just scroll through the group a little bit, and so what I noticed, obviously for me anyway, last week was like a full-on vertex displacement galore week, and so I've seen a lot of people doing doing stuff with that too. Workers displacement week, yeah. So yeah, Lasse did something too, you know. And here, Dennis, this is actually something I enjoyed quite a bit. I really like this graphical style he's doing there, and yeah, it looks like an indie game. And oh, look at this! It's so beautiful. I love that. So this is really good stuff right there. I think I really enjoy that a lot. And so. Obviously, Nolan's doing things. Ben from Facebook has been doing things already. I think this is a little older. I don't know actually how Facebook sorts... Hey, Omi, thanks for the follow. Finally, come on. I don't know how Facebook sorts these things here. But yeah, see, vertex displacement day. And I think, you know, I've been going crazy with vertex displacement. So it's I've done this let's say the water thing, and it's interesting because I just kind of coincidentally stumbled upon something. I also put it in the comments here. That, I mean, first of all, I tried the same thing in Spark when it came out. And Jonathan here posted something which is an implementation. This is like a plugin for, I don't know, Maya or something. Here, Softy Marsh, so it's probably old. But it's like for Tessendorf voice. Hey, Vogley, thanks for the follow. And Tessendorf voice is a algorithm that mimics water surfaces quite well, and it's described in this NVIDIA paper here from GPU Gems, and this is basically it. So this is like obviously like crazy math bullshit, and I don't know, but you know, I kind of tried to make this in Spark, and I've been working on that, and I actually, you know, got pretty far, and it was a lot of fun. Here, Gassner waves, that's what it's called. So essentially the idea is that to use I'm getting the load up circle more than the stream. What? Load up circle? I know, my Wi-Fi is fine actually. I have a really nice telecom, really fast internet. But yeah, so again, the idea here a little bit is that oh, that looks cool. Shading, lightning, and shadows. Yeah, I looked into shadows too, but apparently shadows you need render passes. There's no way to do, as far as I can figure out, shadows without render passes. You can do ray trace shadows. Anyway, it's super complicated. But basically, so the waves, I've been working on that, and I'm gonna definitely do a patch for that. And the fun thing I noticed is that this is like coincidentally, I noticed that there's this demo here. I'm gonna show it to you. So this is something I did actually in 1993 on an Atari ST. And this is the same stuff. It's so crazy because I used to, like when I was a kid, I used to do stuff like on old school computers. But I didn't do the programming of this stuff, but I used to be a designer. I always did graphics, so I made this image here, right? Well, this is what I made. So here it says JMS. So that's short for my name. That used to be my old kind of like, how do you call it in games? Like when people have their handle or whatever. And yeah, the tune, chiptune style. I can put on some chiptunes. Why not? Let's see. Yeah, chiptune vibe. And anyway, it's so crazy for me to now go back to that same stuff in Spark and basically do exactly the same thing. Just that now, when I did this graphic here, I was still a kid more or less, and now I understand the technique a little bit better. So yeah. So I thought, you know, for today, what we could do is look a little bit into toilet paper again. No, a vertex displacement again. Oh my god, the chat is gigantically huge. It's not readable that nicely. Let me just really quick try a different theme here. Yeah, anyway, now it hopefully looks better. So yeah, I played around a little bit with the channel branding, so to speak, and changed up some things in the Twitch settings, like for the chat and everything. Let me know, what you like about it and what you hate about it, or maybe Bazinga! If sounds are not working or whatever. So okay, so let's go and do some sparking, and I just wanted to walk through vertex displacement real quick, again from the ground up. For the people that might not have been on the last stream and are interested in that. If you all, if you want to see something else, sorry, no, you created a Twitch account for me. That's very nice. I just saw your chat message. Hey guys, so thanks for the follow. So yeah, let me know. Just interrupt me if you think it's boring. But basically, just going through what's happening again. Now we can do vertex displacement in Spark, so that's obviously fun. So let's just take our trusty donut guy. I really like the donut now, and see how it goes. I'm just gonna put it here in the camera, and now we have our donut. And now in the material, then that's the new thing. You can go patch asset and do create patch asset, and then it makes this funny colors, which is the normal, and then you can, in the material, you only have the input color right now, but in the patch asset you also have the output position. So what you don't want to do is use this patch asset to actually do stuff, but you want to set it up in a way so that it just passes stuff through, which you can do if you, for example, put another input here and call it position, right? Make it a vector 3, and then inside of it you just want to do a little add thing here, which allows you to add your value to the position of each of the vertices. Why is it not? Okay, it wants 4, so we're just gonna add wiggle that around. Okay, and now the weird thing is that now you have to do a new patch asset, right? Go to the torus and put up this patch asset, and now you can put a value here, and you should see that. Oh no, sorry, no, that's even weirder. Now you have an input here, position, and if I put a value here, then you change the position of the vertices, right? So basically, this is like obviously like a super weird workflow. I'm just gonna, I don't know, delete all of that and start again, because what I did, and I'm gonna put the asset again on the Dropbox. There's a Dropbox link actually, which will contain most of the stuff we talk about tonight. Hey Sergio. And that is actually on the Twitch page. So if you want to look at the stuff or join the Discord, it's gonna be there too. Okay, so long story short, I did a pass-through thing, and I'm just gonna drop the pass-through shader here. I can get my donut again. And then here in the material, I can just put pass-through, and now I have the 2 inputs. My donut is gone now. Why is that? Well, this pass-through asset is actually just passing through the information. It doesn't contain any logic, so I need to put a color in again so that you see something. And you're still not seeing something, so because you need to put also the vertex, the local position in, and you need to multiply that local position, with the vertex transform, the model view projection. And the reason for that is that this way the points actually end up in camera space where you want them. Okay, so now our guy is orange, but you know, we could put any texture in actually. So I mean, I don't know. I don't even know if we have a texture here. I don't know. Let me just quickly search for texture. Okay, I found a great texture. This is the texture. Maybe someone remembers this texture here. Isn't this beautiful? Check it out, guys. This is a texture. Here. Beautiful. Alright, and you can just put this texture or any texture here in the color, and then you will see it. And now if we want to displace our vertices, we can just again put a little add here, and what that means is that you take the local position of each of the points of our object and add something to it. So obviously we have x, y, and z, so we'll make it a vector 3. Now it's gonna complain because it's actually 4 vectors, 4 tuples, I think that's called. But anyway, channels. Doesn't matter. This goes too far a little bit here. But basically now, if I put 1 here, boom, it's gone.
Fuck off!
Sorry, it takes me too long to load the sound effects today. All right. So why is that? Well, you know, because the texture space is just the scale is way off, so I have to put a lower number. So now if I can, you know, put it up, I can basically what it's doing now, it's moving the vertices up and down, right? So that's something.
Surprise, motherfucker.
But I mean, that's obviously boring. I can just take this guy and just move it up and down. But here you see, like the null is still at the same position. The vertices moved up or down, right? So that's boring, but I can obviously do something more interesting and take a sine, for example, and I'm just gonna swivel that guy around and take the y, or let's say I take the x coordinate of the point. Oh shit, I hope that works now. Put that right here, and then I have only one value, and I have to put it, well, just on the y channel, for example. I can add it, and now it is actually working. So, but the wave is still a little bit broad. That's too long, so I want to make it shorter. So for that, I'm just gonna multiply this guy here, and oh wow, and it's like way too much, so I have to use another multiply to bring the values down. Oops, that's too low. You should be seeing something actually at that point. I think I actually made something. Did something wrong here. Let's see, why is that wrong? That's the y position, that's right. That's the x position. Alright, we're just gonna do this. No, that doesn't work, so it shouldn't work. Let's just do this. Yeah. Well, you know, you can watch it. You can watch it if the Wi-Fi is bad. You can watch it in the recording. Shit, it's not working the way it's supposed to. Let's see. It should work actually. Take the X position, do sine, edit. Why not? Okay, but we wanted. I'm just gonna get to that in a second. We also want it moving, so I'm just gonna add runtime to it, which will basically add movement. Oh, so there you go. It does work, so that's great. So we have the guy wobbling around. Maybe it's just. Maybe this has to be higher. Oh yeah, great. It has to be way higher, but now runtime is too fast, so I'm just gonna... Oh yeah, look at this. Oh man, hallelujah. Ah, beautiful. Woo. Okay, it did work. So now we have the guy wobbling, but now the thing is, well, let's see, maybe we can load any other asset here, and let's just put a statue, for example, or whatever you want. And yeah, that guy looks nice actually. I'm gonna load this guy here. So we have to adjust the values, obviously, if the scale of objects change. You will see this Buddha. And now I'm going to put our material on the Buddha, see what happens. So this object actually has two materials, but that's not a problem. We're just going to put our materials to the same, with the same material to it. Oh, look at this. Now we have, oh look, yeah, nice. That's the Spark Buddha. So now obviously the waves to... Oh yeah, beautiful, beautiful.
Bazinga!
Oh, I like the sign. And sine wave. And now let's put the right material on it. Where is it? Color. Yeah, that's the Buddha. Oh, yeah, it is actually doing the Buddha thing. Right, but what you will notice is that if you want to now, move it on the axes are different, obviously. Apparently in this the coordinate system is flipped in this object apparently because it's moving in Z, and we put it on the Y channel, but we can put it on X. Now it's doing this, but it is always moving only in one direction. So if we go to the arrows for a second, what we would expect actually from displacement is that it's not displacing in the world space, but it should actually put the surface out, right? So essentially, to give you an idea of what I'm trying to say is, if you have a donut, right? Let's just draw a donut real quick. Hold on. I'm gonna use my Wacom. So we have a donut. Now what's happening is that the sign is going up and down in this direction, right? But what you would expect actually for a displacement, usually in 3D, is that the surface comes out in all directions. Right? So what we're now doing is we're taking a point on the surface of our donut, and then we're moving it up and down along a sine wave. But what if we want to move it in the direction out of the surface, right? So, well, we're in luck because there's something with which we can do that, and that's surface normals. That's what it's called, and this is actually exactly what we want. It's a vector, so to speak, an arrow going in the direction of our surface. So if this is like a polygon on the donut, this is a normal of this polygon. Let's see how we implement this in Spark. So we actually have something which does exactly that. So we have a vertex attribute called local normal. And if I add this to our guy, it complains. Hold on. Probably have to swivel it around again because it wants 4 channels. Oops, what's going on now? Oh, that's the Buddha the way, something. No, so what's happening is that the donut is gigantic. If I zoom out here, hey, it's Dev Schneider, thanks for the follow. Here, I see the donut now, so it's gigantic. So I'm just gonna scale it down by making it a little bigger so you guys can see. Scale it down, and now you see that it's... I'm just gonna, again, sorry, use the other texture real quick. Yeah. And if I now take my old trusty pen and put the X in this here, then I see that I can now... Oh, it's way too big. So I have to do the normalization trick again, where I drag the device here and divide the position by the screen size, and then it goes from 0 to 1. So see, now I can actually scale the donut, and it behaves as you would expect, right? It's not just moving up and down, right? But it's moving along the normal, so it's basically blowing up the donut. And we can do that with the face mesh too. It looks pretty cool with the face mesh. Let's try that. So let's put the face mesh and then put our material on it. And that's the guy, that's me. Yeah, that's me. I think that's me. Yeah, so but let's just put the proper texture on him and do a texture extraction from the face tracker, and then put this texture in our color, and then we should have the guy properly. And now if I just go around, whoop, I'm gonna make him... that's a little bit inappropriate, I think. Maybe let's put a different... I don't know. How about him? You recognize who that is? Anyone in the chat? Who is that guy? Who's the guy? I have to... I'm gonna pause until someone tells me who that is. Ah, there you go. This guy. Ah, yeah. Right? So... this is the best face shader we've ever made. Yeah. He actually left Apple, you guys know that, right? I wonder what he's up to now. Doing his own cool... sound effects, maybe. Or...
Stop!
Maybe he's also doing... Billion impressions filter. Yeah, probably.
Surprise, motherfucker.
Johnny Ive is doing sound effects. Who knows, right?
Bazinga!
But yeah. Okay. So and now, what if we want to like you know, move the guy? So what we want to do is actually he is making AR glasses for sure. That's amazing. Is that true? Do you have a link for that? We can post in the Discord. Oh, by the way, I'm gonna look into the Discord, see if something's going on there. Where's my Discord? Oh my god, so much shit going on. Nothing going on in the Discord. So guys, if you want to keep the conversation going, join us in the Discord. Actually, Juliana's kind of managing this a little bit with me. Thanks for that. That's amazing, and that could be a really nice place to chat and exchange Spark-related stuff. Hello, sir, Joshua Davis. Is this Joshua Davis? Show your face, Joshua Davis. Hello, sir. Yeah, so this could be... Oh yeah, nice, man. Hey, good, welcome. That's cool, that's cool. I mean, yeah, I'm gonna wave to you. So again, we want to add the animation back in. So what we're doing is we're scaling the normals just along their vector, right? But we want to scale the normals with a sine wave. So that's what I'm going to do now, hopefully. So I take the sine wave, and instead of scaling the normals now with our... Here, I'm just gonna zoom in a bit with our screen pan here. We're just gonna scale them with our sine wave. And there you go, you have a fucking crazy Joni Ive. It's obviously way too crazy, so I'm gonna tone it down. Oh, this is the wrong button to tone it down, apparently. Oh shit, that's crazy. It should be, I suppose, here after the sign. Yeah, but yeah, so yeah, so it's interesting. You can already make a nice filter out of that, I suppose. Let's try. Yeah, it looks kind of cool. Yeah. All right, so this is it. So it was, oh man, we are at half an hour already. But like was a half an hour walk through the new vertex displacement, and I prepared a little thing. So if maybe you don't want to do the whole patcher stuff, and maybe you're more like a I don't know, not wanting to spend that much time doing that stuff. I prepared a little thing for you guys, anyone who might be interested, and that is, I'm trying to pull that up here on this side. Come on, hold on. It is this. It is. I did an update for the glass shader. And this is actually now like super easy to do transparent stuff with wave stuff in it, and I just wanted to show that to you guys. And if you like it, like if you're interested, you can go to my Gumroad and check it out. So I'm just gonna walk you through the process really quick because it's like super easy compared to what we just did. So I'm just gonna open a new file, discard that guy. Well, actually, no, let's change it in today's. We're gonna save it in today's Dropbox. Why not, right? Then you can just check it out yourself. Because like the glass shader is obviously more stuff going on than just that. So where was I? All right, so starting from scratch here. So I'm just gonna basically take the shader. I'm just gonna drag it in, and the cool thing on this shader is that you don't even have to use patches, like at all. You don't have to use any patches. So let's get our torus. This is the torus from the library, right? It's the same guy we just used. So you just go to torus, put the glass on, and now it's already wobbling around. The only thing you have to do is go to camera, texture extraction, go back to the material, put it to camera texture, and there you go. That's a glassy, wobbly guy. And you don't even have to touch patches, like at all. Like if you're not the patches guy, you can just throw it in and do your thing. And you can actually do everything here directly in the material. So what we just did with the normals, so now it's actually moving in world space, the displacement, but if you click along normal surface, it's doing the same thing along the surface. And obviously the distances relative to the surface are smaller than in world space, so you have to just put a little bit lower numbers, and then it will look a little nicer, as you can see here. But the cool thing also is you don't need to make it look transparent. You can also, if you put 0 here, you can make it look like I don't know, reflective something, right? And again, you can just use anything you want. You take the Buddha guy. It's gonna load for a second. Put it in here. Right, just throw it on. And you should have a glass Buddha, hopefully. We will see in a second. There you go. So you have a wobbly Buddha. And now obviously this object is bigger than the other guy. So you have to adjust the values a little bit. So maybe more displacement. Yeah, so that looks cool. And then maybe the wavelength is a little high. So maybe this. Buddha likes to chill, right? So, and you can put the transparency back on. Boom. Reflective and transparent Buddha. You don't need to put any reflection in the transparency. You can just use it like this. And you can also, this RGB thing, you can just turn it off. And the refraction, you can turn it off also. That is not super useful in this case. But this kind of looks cool, right? I would say, yeah. So yeah, super easy, super quick. You can get it on the Gumroad, but you can obviously do more interesting things with it. So, for example, just do one thing really quick, and then we're gonna call Lasse. Hey, Lasse, are you here? By the way, are you? Let's see. Are you in the chat? All right, I have to think. Send him a new link. Okay, so really quick. If we do a face mesh. Oh, there you are, Lasse. Yes, very nice. So put the guy on, and then here, look at this. This looks kind of cool, right? But then we can take it a step further, and now we have to just put back some patch logic back in. So what we can do is just take the wave height for each of the direction, for each of the axes, and connect that with whatever you like, really. But for example, how about the 3D rotation of the guy? So this, now you're not seeing anything because it's like way too crazy, because the values are way too high. But if we just take a multiply and set it to something lower, this is still too crazy. See, this is kind of cool, I suppose. You can do cool abstract shit with it, like that. Still too high, right? So yeah, like this. So now when he's moving his face left and right, the distortion changes. Let's get some dispersion back in, and maybe some reflection back in, and then maybe, you know, use not along the surface normals, but the other direction. Oh, see, that's kind of cool, but we can make more waves in there. Yeah, and you know, there you go. So this already kind of looks cool, but you can also use it to connect it with anything you want, really, obviously. So there you go. It's available for pre-order right now. Pre-order because I want to use this little Twitch as a tutorial. And yeah.
Bazinga!
So let's see if we can get Lasse on. Yeah, so I sent Lasse the invite link. Hey, there he is already. Boom! That was quick. Come on. Perfect. All right. Hey, Lasse, can you hear me?
Yeah, I'm hear you clearly. It's like I have you on the screen on the side here, so sorry if I'm like looking both ways.
It's great. It's great. So yeah, everyone, welcome Lasse. And again, let us know. I think you can hear him as well. Everyone in the chat, just let us know whether you can hear him or not. So hey, Lasse, why don't you introduce yourself a little bit? And I'm not even like I said, I'm not even gonna try to pronounce your name.
Lasse, you're doing quite a good job. I have heard way many different ways of saying my name, but the name people struggle the most with is the last name, so we're not gonna jump into that.
Well, but how is it? I mean, Lasse, fair enough, but what's your last name? How you say it?
Mejlvang Tvedt.
Mejlvang Tvedt.
It's a mix. It's a Danish and Norwegian name. So yeah.
It's crazy. So anyway, Lasse, super excited to have you here. We talked a little bit before the stream what you're going to talk about, and it's going to be really, really amazing. So I'm just going to basically, you know, lean back and be amazed by the stuff you're going to show us.
Perfect. So people wonder, like, probably like, who the fuck is Lasse? So I'm a creative technologist. It's just like a nice word for a potato, like, because a potato can be used for everything. So what I mostly do is like I do IT consultant. Like I work in a company called Vertices and do IT consultant. But there I also help people choosing the right technology and build websites and stuff like that. I have some work if people are interested in seeing it. But in terms of Spark AR, I've just started to do commissioned filters because Spark AR was like, it's just something I randomly got into. I was not doing too well, so I needed to get my mind off stuff, and then I learned Spark AR, and here I am.
We are super excited to have you in the community and in this stream, and yeah, looking forward to seeing what you've been up to.
Yeah. So I'm gonna share my screen now, and let's see. I'm gonna show what we're gonna create. I shared in the group yesterday. Do people still hear me? I put on the screen sharing now.
Yeah, we can hear you fine.
Okay, yeah. So I'm thinking like we have a lot to cover today. So what I'm gonna do is like we're gonna build.
I just want to say to the people on Instagram that because I have an Instagram live thing going on at the same time. Sorry for confusing you.
Yeah,
but
no
that they're not going to be able to see anything you're talking about or hear anything because it's just here on my phone. Yeah, they can maybe say hi to, I don't know. Yeah, say hi to Instagram. But yeah, again, sorry for that. Keep going.
No worries,
sorry,
no worries. Okay, yeah. So I shared yesterday like something we're gonna make today, and I'm gonna like explain through like the whole process of it. Like I'm gonna go into every detail of like how to make this, and yeah, we have prepared some files because we're gonna need a lot of objects in here. So yeah, and under the process, I'm gonna cover like everything about promises. Like a lot of like that was it 2 releases ago where everything like the old method of like getting stuff in scripting got departed.
I don't really know when it was. I think it was 85, so like 1 release ago, I think.
Yeah. So people started panicking and all this, and like this is the apocalypse in Spark AR, and like people are never going to use scripting again and stuff like that. So I'm gonna try explain why probably Spark did this change and make people to understand it and why we need it. So I don't know, did you share the link of this one? Let me just jump.
Yeah, good point, Lasse. Thanks for reminding me. So Lasse prepared a little scene file. If you want to follow along, you can just go to the Dropbox and download it. You will find the link actually on the Twitch main page. But I can also put it in the chat real quick again and in the Discord. So Lasse, you can keep going. I'm just going to look for the file.
Perfect. Okay, so I prepared this file. Let me just save it quickly. Where it's like, it's basically as a scene with a plane tracker, a group, and a bunch of spheres. And this is, if someone from Facebook is watching, or the Spark team, if you select many items today, it's you don't get a number how many items you have in the scene, which is something they should fix before, because now you don't have the naming when you're duplicating. Everything is just
That's an interesting question, actually. Is anyone from Facebook watching? Let us know in the chat.
No, but I have made them aware of it. We have been talking about it, and I've been sending like a ton of bug reports on it.
Okay, good.
Okay, so yeah, people can just follow along when they have the file. So the first thing we're gonna do is like, I can explain, like here is like all the spheres are overlaying each other now. They just duplicated, and it's 256 of them. So what we have to do first to create, I think we're going to do the grid animation first, like this one, because this is like the most, if you know how to do this, you will get far in creative coding and stuff like that. So when you're ready, you just open the script file. We're going to clean up a bit. Let me see, we still want this one. Yeah, and so the first thing is like, I'm going to show, like we talked a bit last week about promises and stuff like that. So the old way of finding stuff was like find something, and you went to scene root and then find, right? Or you could use child if you already had selected a element, and something. The problem here is like this found one thing at the time. I don't know if people see the code, my editor clearly.
I think I have the chat over it. If you just move it.
Should I move around a bit?
Well, okay, either way, yeah. Thank you. Hey, Pictoglaze, thanks for the follow, by the way.
Here we go. Right, and this was the parts now in favor for the asynchronous API, and people were like, "What the fuck is asynchronous?" So JavaScript but like the programming language Spark is using is their own implementation of JavaScript, and by default JavaScript is synchronous. So it can, meaning synchronous, it can only do one task at a time. So you can't like run two tasks at the same time, and that's have become a problem when we start in JavaScript. We're starting to like call more especially in web development, when you have to get assets from another website. It's like if people were early on and used the external texture, you still have to wait for a server to respond with that data to you, right? It doesn't happen like right there and now. You have to request a server and wait for it to respond and send you the files. So that is basically why we have async. Asynchronous is the opposite of synchronous, meaning you can run multiple tasks at the same time. And that is, I'm going to show you like how the find works. So if we do like this, let's do group 1. Group 0. Now you see you got a message here, and that is so now it has to find this, and we have to wait for this to be found. So I was like testing it earlier today. It was like testing. So when you do a find, basically, I don't know if people know this hack. I'm going to bring this up here. So if we duplicate this, and if you rename a project file to zip, give it a zip extension, and unpack it, you will have like the whole project file, the JSON file with all the project configuration. You can see it's like a bit. Can I bring up Chrome? Let's do that. I think so. We can open. I'm going to show you what's in it. This is like. So this is basically what's in the Spark project now. Here you have like this. All the
Sorry, can I just? How did you get that into Chrome, and why did you get that into Chrome?
Okay, so now it's like I don't know, like if you know this hack where you like many project like softwares, Sketch and all that. When they store project files, they store it in JSON. So basically, when they have like this project file. If you rename that, like give it a zip extension, you can unzip it, and then you get like the actual project information, like configurations and stuff like that. Now it opened, so now I don't need Chrome anymore. It's and here it is, like this contains like all the data about the project.
So you were just using Chrome to have a nicer layout and not having to look through all this mess, but it's colored and okay.
Now it loaded the file, but you see like it's ginormous. It's like super long. So what what the Spark does, every time you run the find function, the find is over here. I don't need this one anymore, right? It will start iterating through this massive file. So you can imagine that takes some time, right? And a problem like we saw like people doing when using find, they didn't cache the result. So like they run this find, some people could run it like at every frame, and it's a lot of it's a big job to find like the one specific thing in this big file, right? So, and that is, so imagine now if I running find, let's log this, found, right? So this, now it doesn't give like time, but like in the old API, this has to be defined, has to be resolved before you can do something more. And that is matters with all animations. If you have like created some animations with what's it called, patches and everything, those animations will wait until this object is found. So what if you trying to find 5,000 of objects, or like in our case, we have 256. So I made a demo today. I'm not going to open that project because it's like such a big file. So I put the 5,000 objects into a project, and I try to find, when you tap the display, it will try to find all of them, and then try to execute the code. So notice the animation here on the sphere bouncing up and down. Notice what it does when it starts looking for all the objects. Let's see, it's coming now. You see, it stops, it lags basically. And here it's got the information. So it's when you look for stuff synchronously, it will not run the animation until it have like found all this, because it's the task coming after the sequence cannot be done before this find task is done.
So this, the output, they start looking for objects and found objects, and the time and stuff. This is something you put in, right? The console, yeah. Mm-hmm.
Yeah. So this is like a stress test. So what?
So really quick, Nolan is saying the file isn't opening for him. I don't know, Nolan, is it? What's not opening specifically? Is it like the file in Spark, or what is it?
Whoa, now it's
stress test file is not stress, like Lasse just said. As far as I understand, stress test file is not included in the Twitch files on the Dropbox, right?
I sent it in there, but it's like, because it's like so many objects.
Spark crashes. Okay.
Yeah, Spark crashes.
Yeah. All right. Well, you know.
So like I'm on a full spec MacBook Pro, and it struggles with it. And you see, it took 3.5 seconds to find all the objects, right?
Yeah.
So what's interesting now? It's with the async API, right? Then we have like the new, like the replacement find first, and that will return a promise. I will come back to promises. So this will now we will start looking for it, but it's not found. Like if I do this now and try to log this. I try to look for group 0 and log it right after. You will see it will trigger right away. Let's see, open here, but it doesn't return anything. Like in it just like this empty object. In JavaScript, it will return like a promise object, which is like, it has like 3 states. It's like pending. That is while it's waiting to find the results. And then it has like the fulfilled, which is like when it has found a result. And then the last one is rejected if it like failed somehow. So that is why we have like this in. So what we can do is like, that's why we have like the promise. So this one returns, find first returns a promise, and a promise has this method then, and this run runs when it has found it, when it's done have found the object, right? So if I do like this, and then you will see it will log probably a scene object, right? So here is hence the asynchronous. If I do dlog found, so in the old way this one, if the code was synchronous, it will run this, and then this, and then found, right? But now it's, I have the login there actually. So what happens now is clear. If you see here, it's like it will run found before the object is found. So if we do like look for objects, let's do that. That means like while it's looking for objects, you can actually run stuff in the meantime. And here comes the rest of the demo, because with async, it will look for these objects in the background, right? In parallel, if the Spark team have done it right, and it looks like apparently I've done that. So now it's next click, it will do the async way, finding the objects. And you notice the animation didn't lag anymore, right? And it found all the objects in 97 milliseconds versus 3.5 seconds previously.
Yeah, I think that calls for...
So that's the difference between async and synchronous. Is like async, then you can run a background task. And,
yeah, so it's basically while it's doing other things, it's finding the objects, and it is also apparently finding the objects much quicker than in sync. So probably it's running a lot of threads at the same time, or why is it that it can find the same amount of objects in like a fraction of the time?
Yeah, so like in the synchronous way, it finds one object and then we wait. Like it finds one at a time, but in the new API, it finds like you can do like the pattern find by path, right? And that means like in one function you can find many objects. You used to have to be loop to find them. So that is so now I'm just going to write some code that shows. So the promise, all the people that have been working with code in Spark now the past weeks should know like about promise all, but I can explain it if people are curious. So a promise, since we saw like previously that find first was returning a promise, right? Find first. So this returns a promise. So what we can do, we could basically do like this as well, const promise 1. Let's just do like this, 2 and 3, and let's do the plane tracker. I can close this one. The plane tracker we need here, I think we're gonna in our project, the example, we're gonna use the plane tracker. We're gonna use the group, and then we're gonna do like the find by path. And this is the interesting, because the new find by path, you can write a pattern. So we know we're gonna look in. So we want like this one, the third promise, to find all the spheres, select all the spheres that's under the group. So what the new find by pattern, let me bring up the window here for this. Where is it seen? It kind of explains it quite well there. Scene object base. So find by path. So this here you see it returns a promise. But like find by path, it lets you like write wildcards. It's similar to like if people know that know programming already, like been working with file systems and stuff like that. You know, like glob, you have like a glob pattern. So this one is like so now it will like select anything at the root. I need to change this. This one we can. There. So now it will select. Let's just play with it a bit. Let's put it. So now I put the third promise in the promise all, and the promise all, it works that way. Like you put an array, a list of promises in there, and it will like wait for all of them to resolve before. Then when all of these elements are loaded, then you get this function as run. In my case, it's an anonymous function. So let's do like a log and stool assets. So this one should just return an array now, right? And like the first element of the array. Here it says 2 nils, but if we really check them, for each, let's do this quickly. Object, and then we do, I think this works, object name. That should give the name of the selected objects. And this should be device and plane tracker, right? You see, it took all of the, all the top layers of the, like we're looking for, from root, we're looking for all the children. Not grandchildren, but just the children. So this is why it returns device and plane tracker. So what's interesting? So this is like basically a wild card name. So we can also like do like everything that starts with the D, and then it should only return the device. Let's rerun it. Right, and the same goes with like the other way. We can do everything that ends with, I don't know if this, we can do this. So everything that contains the word, the letters lane, right? And the same, and then you have like double, the one you asked earlier about, right?
Yeah.
Which is the double. Then it will recursively, then it will climb through down the scene tree, and it will look for everything. We can just run this and see. It will take a while, but now it returns the names of everything. So if we're back to our problem, we only want to select the spheres in our plane tracker and group. So what we can do is we can do plane tracker and then group 0, and then we want all the top layer of spheres here. So all children of the group, basically, we want all the spheres in the group. And if we run this now, let me see. Plane tracker now. So if you understand it right here, it's like, okay, it will you actually write the file path for this, for what you're looking for. So we start with the plane, and then we go to the group. So we select the group in that path, and then we do a wildcard to select everything that's a children of group 0. And then if we clear this, save, then it should return all the spheres. So that is basically defined by path. I would recommend people playing with it. It's like, this is like essential when you want to like do formulations, what we're gonna do. So what we can do is like return promise 1, 2, and 3. So now it will look for all these things. So we're looking for the plane tracker, the group, and then all the spheres inside the group. So this will return when all these are found. And just to be like clear on the async. So while it's looking for all of these, we can still do something like while it's looking for it. And that's why you will see like do something before it's found all the elements, because that one is happening in the background. But with the old API, like you saw, it was then the animation stops up, basically, right? Because it has to do one by one. But here it's like happening in the background now.
It's also super useful,
really...
I think, that you can find a lot of objects at the same time. That's really cool.
Yeah, and that is like why they have changed the naming of it, because now you can have like objects that are named the same, because now you can use find all and you can look for like one specific name and use path and stuff like that.
So before it wasn't possible to have two objects of the same name?
No.
I see.
You couldn't like look. You could probably have it, but you could only find one of them.
Oh, I see.
You could not find both of them because you only had like the file find and child, which is there's some crazy looping going on, and like because as I showed I have done this previously, like in the old API, and it was like super slow and stuff like that. So let's proceed on this. I think did that make like async and synchronous clear?
Yes, I think you did. Let's do another.
Let's see.
But also, guys, like if you have questions for Lasse, just type them in the chat.
Yeah. Now it changed like the window structure a bit, so it's so I'm kind of not looking that much at the chat.
Okay, so I will let you know if anyone says something. I'll let you know, and I can just be proxy for asking stupid questions.
Feel free to ask. It's like I said, I've been working with this for like the past 10 years, so it's for me it's like kind of automatic thing. So I like that's why I want like people have to let me know if I'm not explaining it clearly enough.
Yeah.
So let's move on to like our goal for the night. It's like we're actually gonna make this. We're gonna take all the spheres, put them out in a uniform layout like this, and then animate them. Which I don't know in the patch editor. It's like people know that I'm not like the biggest user of the patch editor, but if you were to select that many elements in the patch editor, it's impossible. Like you would have to create 200 patches, right?
Yeah, I mean, obviously some things in code, actually probably most things in code are easier to do if you know what you're doing. And also, I mean, I think what I like about the patch editor is that it's just fun to try different things. But obviously, if you are well versed in code, then it's just as well possible, right?
So maybe in the future they will Facebook or I keep saying Facebook Spark team will like add like a way to loop through your like a path inside the patch editor. That would be like
what do you mean?
So you could loop.
Oh yeah,
like
we definitely want for loops or like loops and patches. This is something really cool. I have been talking to them about that quite a few times actually, and showing them how you do it in Houdini. In Houdini, this is a node-based 3D program, and there you can do loops. So it's definitely possible.
It should be possible. Yeah, and the only problem now I noticed is when this project configuration gets super big in patch editor, it starts lagging. I noticed some people complaining about it, but I think they're working on a solution for that. So that is basically the new API update and like why they are doing this. It's like it's a lot more performant. And also it's like it promotes like some good coding architecture because I noticed a bad pattern I usually saw was like the set interval. If we just let me just do like an example on it. I saw people do set interval. Right, this and then run this like at so every 100 milliseconds. I saw people like always when they like were to adjust something, like give a new object like a new position or something like that, they would do like this, find, and then like transform, take the position of it, for example, and do something with it. So what this will do is this will run like the find. It will look through the big project file every 100 milliseconds, and that's a super bad practice. Like if you only did it this way, object, and then did the find stuff outside before, and let's do like this, then it doesn't have to look, then it only looks for the object once, and then it will be a lot quicker to find the position later, because it doesn't look for the object every 100 iteration, because now the object is like stored in memory. So it's basically, I try to explain it with like, if you're going to the shop and know where to find all the products, the shopping trip will be a lot shorter, right?
Yeah, of course.
But what if you, every time you went to the shop, there's like, you didn't know where the groceries were, then you will have to run around this shop and look for everything. So basically in Spark, since most of the phones are recording at 30 frames per second, you have 33 milliseconds to find the object, and then first to find the object and then do the calculations. And if it doesn't manage to do all this in those 33 milliseconds, then it will lag, like starts lagging. So what's nice about the new API, you're kind of forced to like store the objects in cache.
Yeah,
in memory, so it's like easily to find it. So like it doesn't have to like look through the whole project tree.
I think that's something Noland also mentioned on the last stream, that basically this forces people to write cleaner code in a way.
Yeah, definitely. It's like 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 when you do me that work as a full-time developer, I see this. I do always like you should always cache them in like put them into variables after, like if you're looking for something in a tree structure, always save the result. If you're going to reuse it later, save the result in a variable, because now it doesn't have to like go through the whole tree structure again to look for it. So basically what I've done now is like we have like these 3 promises, and then we wait for all of them to finish, and then since the promise all is returning one variable with all these results in it, I'm reassigning it to variable names, so it makes it easier. They're already cached when they're in the assets variable that is returned, but I'm like, it's cleaner, like give it a nice name and stuff like that. And in promises, the way you put it in the promise all, it will come in the same order out. So asset 0 will be promise 1 in this case, and asset 1 will be promise 2, and asset 2 is promise 3. And that is where this is like basic JavaScript stuff. I think Spark has a good guide on it, like get in the intro to scripting, like on the data types. So yeah, let's proceed to our. So now the interesting part comes. So now we have selected the plane tracker. Let's just confirm that we have selected it. Plane tracker name. Plane tracker. It returns plane tracker, the name of the plane tracker, right? And the same with the group your name. Yes, and then here's the interesting part. When you use find by path, it will return an array with all the found elements. So this will return an array. This is a weird Spark thing. Like it's not null, because if we select the first element, like the first sphere and return name, you will see like it returns sphere. and we can also like do like the count. Let's do see how many like spheres we have selected. It should be 256. 256, right? So now we have selected all of them, and we can like program it with code like dynamically, like put them into formations and stuff like that. So now it's like the math part of it comes. So what we want to do is like in the example, let's here, like we have put them in like you have like in a grid, you have like rows and you have columns, right?
Hey, quick question from Wilbur. Is he saying you can have multiple promises blocks if you want to do multiple asynchronous things, right? That's the question. Yeah. All right, cool.
Let me see, like the double check. You can have multiple promises blocks if you want to do multiple asynchronous. Yeah, you can do that. And there's like the promises is like I'm just touching like the basic core of it, and like. Let's do something. I actually have a good idea. We can also create a promise just to like, if we do like a delay function and like we say delay milliseconds, and then we return a new promise. So what I'm basically doing now is creating a promise. Promise resolve, and then we're going to use the, let me just do a shorthand version of this, or I can do like this. Time and then set timeout, isn't it that?
Hey, can I ask a stupid question? I said I'm going to ask a stupid question. So what does this arrow do?
The arrow is like that's the new syntax of code. It's like it was introduced in. So JavaScript has like a global, like official specification, and then it's like the different browsers, and like Spark has their own implementation. Like the way they implement this specification is like up to them. But like there's an official like global specification for it. So normally like. A normal way of writing a function is like function name, right? So, but like in ES6, I don't remember when that was released. They introduced like a new syntax. We need this as well. So it's called the arrow function. So it's just like a shorthand. So I could like write function name and then do this. Those two would do the same now.
Okay, cool. Thank you.
It also has some like in depth. It has to do something with scoping as well. Like some you will have variables from outside the function scope would be available inside here. I'm not going to go in depth for that because then we're like starting on JavaScript 101.
Right.
But what's nice about it, if like, so this, how I could also write this promise here. Now I use the arrow function. So if I was doing this in the old way, I think I would do it like function and then resolve like this, right? And then I would have to like do another return to do this. So this block of code does the exact same as this block of code, but this, you see, it's like a lot shorter just using the arrow.
Right, so it's a shorthand for a function.
Yeah, but it's some other special rules to it. It's I'm not gonna go too in on that field. So now what we have done now is I created a delay function that accept argument, which is milliseconds, and then we create a promise, and that promise is resolves after a certain amount, like after the timeout is over. So if I do like a promise for and then we do the delay, run that, and let's say 3 seconds. I think it's that's 300, now 3000 milliseconds. If I add this in here now, and then the log ready. Now we will see, like, let me just check through promise delay. Yeah, looks right. Now you will see, like, it will not call ready before this promise is resolved. It takes 3 seconds now. If I just restart, it will, after 3 seconds, it will resolve that. And that is because this block of code takes the amount of milliseconds we specified to resolve the promise. So that's basically like how promises are basically, it's waiting for a function to be done.
Yeah.
And this is very handy if you want to delay animation and stuff like that in Spark. I've helped some people with it. Should I just leave it in there? Yeah, and commented it out. So we can share this afterwards. So yeah, back to the spheres. So now we have selected all the spheres, and we're gonna position them in a grid. Let's see here, with columns and rows. So then we have to, like, since we want to uniformly distribute them, we kind of have to find out, like, with the number of spheres we have selected, which was like 256. We have to calculate how many, like, rows and columns will this fit into, right? So that here's the math coming in. So we need rows. So to calculate how many rows we can do, like, if we want to evenly distribute them in a square, we do, I think, floor. Now we're not using the reactive code now. Now we're just using regular syntax because we haven't, like, these are not reactive signals. It's kind of hard to explain the whole signal thing.
Yeah, can you maybe, not to get too deep into it, but you're saying you're not using reactive, but that means the same thing could be done with reactive, right?
Yeah.
And as far as I understand, you should be using reactive. Is that true, or doesn't matter?
So that is really depends, I think. That really also, like, I don't know, like, how they implemented it underneath the hood, because, like, this one is not the sphere, like, array is not a signal. The difference between signals and like, when it's a signal, it's how do I explain it? It's a signal is like something that's updated every frame. So basically what I'm doing here, this can be like, if we were doing reactive coding, we would have to do bring in reactive first. Let me reactive. Is that it? Yeah. So then we would do, like, floor, right? And inside that we would do square root, and then do the sphere length. Let's see if this works, like, and we can compare them. Let's just give this a random name. So if I log rows now, that one will be just a number, 16, because 256 is 16 rows should be right. But if we do row 2, that should be a signal now, right? But since we don't need this number in a signal, I think it's a bit unnecessary to convert it to a signal already.
Yeah, I mean, to me, like, the whole signal and reactive stuff is, like, totally weird. Even, like, if you compare those two lines of code, right? I mean, I guess you can get used to it, I suppose, but like the second one is kind of like everything's backwards, right? So
Yeah.
it's definitely so. But okay, but you're saying it's not like bad style or whatever to use not
Yeah, I'm
signals
gonna
and
come into
spark.
that because with signals we can't really loop. Then you would do the have to pin the last value and stuff like that. Now we're just trying to figure out how big our grid should be, like how many columns and how many rows. And if we got that as a signal, I don't think it will work in like a JavaScript loop as well. Let's call the columns and that is I think it's math floor. So if people have worked with the processing, they have probably used this a lot. I think processing actually have like a helper function as well. So here, like this is a function for getting like a equation for getting the rows based on the length of a number. So this here we could paste a random number in, and it would like calculate how many rows it would require. And what we're doing is like we're taking the length of the array, which is how many items we have, like how many spheres we have selected. And then we have to use this, I think, spheres length and divide this on rows. And then we will get the columns. Let's see. I think both of them should return 16. Oh, shit. Here. Yeah, and rows. So I'm gonna try a bit quicker, or else we're gonna not get done today. So now we're gonna do the loop. Let's do. So in JavaScript, this one have been around for ages. So what we want to do is first we're gonna loop through the rows. We're gonna calculate the positions for the rows, and then we're gonna calculate the positions for the columns. So if we imagine this like as a 2D graph, let's do this. I'm just gonna trying to remember here now, rows, and then E++. So what this will do, this is like a loop for function. So this is a very different for function. So what we do is it accepts before we start looping, we set like the Y position to 0. Like this is the row number to 0. We can do it easier. Row, and then this is the condition. So this loop will go until as long as the row is less than the max amount of rows we have specified. And then after each iteration, we increase the row. We go to the next row. I just heard my AirPods are running out of battery now.
Better be quick. I mean, you can basically what you're trying to do is you're just looping through all the spheres, right? So if you want, you can just like copy and paste the code. I think it's probably
I have it somewhere. Let me see.
And the interesting,
I'm just writing it from my head.
All right. The interesting thing here is you can just write the code, and I'm gonna comment on it real quick, because the interesting thing is what Lasse is doing is exactly the same what the shader is doing for when we did the vertex displacement with the sine wave, right? Like if you put the vertex attribute local position, it's doing the same thing. It's running through all the vertices of the object and then adjusting the position with a sine wave, which is the same thing you're doing right now in codes.
Yeah.
Just not with the vertices of one object, but with the positions of your 256 spheres.
Exactly. Let me see. Now I have the indentation is wrong here. Okay, so now I pasted the code, and here is put the width and height as well. And we're still working with the. working with 3D units. So this would like if the plane tracker was working right, and I have some intel on that later. Then this should be equal to a meter.
Okay, that's interesting.
Right?
So they are actually meters. That's very interesting. Looking forward to hearing more about that.
Yeah, so it's because I'm working on a project where I need to like real world the units has to be right. So that's where I learned this. So basically we added width and height, and that's going to be the width and height of the sphere. And then we added index, so it knows like which particle or sphere we're currently editing. So here is like, so here is like looping for the rows, and for each row we're gonna loop through a column. For each row we're looping through the columns, and then I'm selecting the object, that's the sphere, and that is where the index. So now this would be the first sphere that's found by the find path. And I can just save this. And then here we use this. So for the object, this is probably the one thing people recognize. So for the transform X, so this is the position of the object, right? If I just did this, then it would everything would be like in the same column.
Hey, I have one quick question. Is that like it's a little laggy, but is this because of the Hangouts, or is this actually slow on your machine also?
No, it's here is running 30 frames per second. I think,
okay,
or
good.
60.
Right. Okay, great. So it's just the playback because of the stream.
Yeah. And if you remember to notice me if someone have any questions, because it's going a bit quick here now. I'm going to share this code afterwards.
Great.
So basically what we do is like we're taking the position. So since we're looping, so this is in this current iteration of our loop. This is the
Hongwei
position.
wants to see the FPS. I don't know. Is there something you can do in view or something? Can you show FPS?
I've seen it somewhere.
Hongwei, where is it? Oh, show a FPS meter. There it is. I'm seeing it. Down.
There, yeah. Where did it go?
It's below the simulator, maybe? I don't know.
Yeah.
Oh, there it is. Yeah, 30 FPS, boom. So basically, whatever you're doing takes less than 33 milliseconds.
Yeah.
So
and that is because it's already found all the objects, and it starts to do this. It has been looping through it. It only does this once, because after this part of the code where we assign the new value.
Yeah.
Then it becomes a signal.
Essentially, just maybe going back real quick to the signals versus not signals. For the X and Z transform, it's gonna get applied once, and for the Y transform, it's gonna get applied continuously because you're using a reactive function, or how do you call it? A value, I suppose, for that. And the reactive values get updated automatically, right? You don't have to worry about that, because usually what you would need to do is have a main loop which runs like every frame and then update the stuff, but this just works under the hood in this case, right? So basically, if you would not use reactive, and for the Y transform just put a normal JavaScript value, it would not move, right? It would just be static.
Then it would be static because we don't have the time, and it only run once.
Right.
So that's why I put in. So here we're using the sign again. We don't have like a time function like a native JavaScript. So like we need a signal for using this time millisecond.
Right.
So that's basically the same runtime.
And guys, this one line is again like this is exactly the same thing we've been building with the patches before. We take the position, feed it in the sign, multiply it to get the wavelengths, multiply it again to get the amplitude, and so on. It's the same thing, just written out in script. Yeah,
so I can explain that quickly. So here is basically I just want to go through this one quickly. So here we do like so for every particle now, for every sphere, we get like a separate x and y value. So what we do is we multiply. So this is the current like if I do this, it will be spread out more. Yeah, right. So already here we have like with a loop we're doing here the x and y. So the x, this is like, so we set like the specific selected object in this iteration of the loop that should have this position in the grid, right? I don't know if people see all these, how they are positioned evenly out, and the same with y. And with this part of the function, we actually say like we should limit them with inside the size we specified earlier. And the same goes with the rows. Let's do one at a time there, right? So now we have like actually told to position all the spheres in a grid within a size of 1 meter. We can do like adjust this, and the same. And then I have this other part, because now you see like how the objects are like the spheres are positioned from the 0, like the top left corner. So I added some math here, like to shuffle over. So now it's like centered.
So there was a question from, sorry guys, I don't know your proper name from your Twitch channels, but Mr. M Design, I suppose. Is there any speed performance difference doing this in patch versus script? And that is an interesting question. I don't know the exact answer.
I don't know. I think actually my understanding, like after the after what's it called, the update, you kind of noticed like actually patches are using JavaScript, right? It's just wrappers.
Right.
It seems like it, because it's like the input is going to patches. So kind of like if you think about it, this would be like patches is almost like an abstract layer over JavaScript.
The weird thing is that what I don't get about that is that because some functions only exist in script, some functions only exist in patches.
Yeah.
But I mean,
Yeah,
if you say like patches are a wrapper around JavaScript, it would make sense to say, okay, there's a subset of functions that work in patches. Yeah. But why are there functions that work in patches that do not work in JavaScript, right?
Yeah, I think the patches are more like developed, so they have like some. You have more like the functions. Some functions are more like helper functions in patches, while in JavaScript you would have to make them yourself.
Yeah.
But in the end, like when we talk about performance, I don't think patches are lower in performance, because I think when you export, or like when Instagram or like whatever app you're using this, I think patches ends up in JavaScript. Like they all end up like in the same code add, and yeah. I don't know like how low level on the engine it becomes.
Exactly.
It's quite interesting. It's an interesting thing.
Yeah, I would be curious about that too. Whether it's like you suggested, patches are just a wrapper around JavaScript, and then it basically gets to be JavaScript, or if it's like a separate thing where they do like a pre-compiler type, like bytecode type thing in parallel to JavaScript, which I guess wouldn't make much sense, I suppose. I don't know.
Yeah, I think actually like patches are transpiled into, I don't know, I think JavaScript is also transpiled into something else they're using. It would be interesting if they opened more about like this, so we could learn more about the application.
Yeah. I think it's probably also device dependent, right? So maybe it's different on different devices. That's probably the reason why they abstracted away, because they know they need to be able to run on all possible mobile devices.
Yeah, and so like in terms of like workflow, this would be faster to do than doing patches, because we
Yeah,
still
of
can't
course.
loop in patches. But I would love to recreate this in patches one day.
I
Like,
mean,
not with loops, if we had that.
yeah, exactly. Without loops, that's crazy. But actually, you know, people do crazy things in patches without using loops,
Yeah.
but just doing like, you know, pages after pages, just copy and pasting patches around.
As a developer, I'm like, if I can't like do things automatically, I'm like going crazy, like selecting like big groups and stuff like that. It's the most annoying part I think about patches is like I'm using way too much aligning.
Yeah, I love that though. It's kind of like it's very chill in a way, right? Like the half of the time I'm just moving around my patches so that they look nice. Again, and in Houdini you have this auto align thing that's kind of nice. It makes it auto magically, like it makes your patches. Well, they don't call it patches, but
nice.
yeah, the layout. They have like a layout engine.
Yeah. So this is basically the grid. It's like people, we're gonna share this, and like when people, if they have questions, but it's after like the only coding syntax part here is like actually the for loops. The rest is just math, right? It's like so we loop through each like particle in each row and column. Like we find each row and column for each sphere here, and then we position it based on its position. And then we add like the wave. So this is kind of interesting because here we're adding the delay to each. Let me see. So if I did this, add 0, now it will just move up and down, right?
Right. Yeah.
So what we do, what I basically say here, like for each row, add a 500 millisecond delay.
Okay.
And then you get like the smooth, and like if we
right,
do it,
of course,
change this to the columns.
You'd shift the time function, right?
Yeah. Because at first I tried to like do like create like a time driver for each particle. But I noticed like when you start, you have to loop through to start all the time drivers, and then it will actually delay like on the columns as well, or like
of course.
So which is so I wouldn't recommend use the time module if you gonna animate like many things like separately. But if you're gonna animate all the particles at the same time, but like in the same how do we have the same animation on the particles, because now we don't have the same. Now each column has like a separate animation, so this would require 16 time drivers if you want to do it with the animation module.
Right.
So I'm just going to paste the code for the sphere here as well, since people found that one interesting. And remember to ask questions if
I mean, the beautiful thing here, I think, is that it's like really not that much going on, and it makes a really nice effect, right? So that's pretty cool.
Yeah.
I always love the simplicity of like, even of effect. Sometimes the simplest things can look super beautiful.
Yeah, and imagine when we get like audio reactivity and stuff like that in there, you can really create some experiences. Or like in this
Winamp, all the way back to Winamp. Visualizers. Or you guys remember the cool iTunes Sphere by Robert Hodgson? You know,
I actually have an example. I have it up and running. It's for this. I made this website for like this sound architect once. So here's like basically where I have the code from the Sphere.
Oh, the one you're showing right now, yeah?
Yeah. So this is like basically sharing this exact same code that we're gonna use. I have some other visualizations.
The UI looks really nice. What is this?
This is like, so this is a part of my job is like we do. I help design consultancy create branding, digital branding. So this is like for the music engineer we made like an identity for.
Yeah, that's nice.
So we made this visualizer tool. Like on his website, we also have the visualizers actually. The same sphere, which is like you don't have the sound now, but it's easound.no if you want to check it out. But we also made this like visualizer tool, which lets him export videos out to social media and stuff like that. So that's like where I had the sphere, and like it would be interesting to see it with audio activity.
Yeah, you guys, I just want to, you guys remember this thing here, the magnetosphere by Robert Hodgin? This would be really cool. This is like old,
yeah.
but this
Oh
is,
yeah.
This is like, this is a show we're gonna do in Spark soon, very soon.
Yeah. If we like, this would require like WebGL stuff, like not WebGL, but like to be able to transform each particle in an emitter. I think that would be more performant than the way we're doing it now.
Of course.
Because it has like proper instancing and stuff like that. Because it gets a bit crazy if you add more than 200 spheres. So yeah, let's see. I added the code for the sphere. Like, I have the code already. I can explain it. So basically, it's this is like one of the more simpler spheres to make. Let's do the group. Pull it up. Right, and we have positioned all of the spheres. So for each, here we're doing a different loop. So for each object in the spheres list, doing like all this. Do you guys still hear me? Let me.
Yeah, we hear you. Yeah.
I'm just gonna continue until the headphones are dying now.
We can hear you well though. That's good.
Disconnect. Hear me now?
Yeah, it's fine. We hear you.
Okay, perfect.
Audio quality was much better before, but it's fine.
Okay. So here we basically put X, Y, Z. So we create like a random coordinate between 0, 1 and 1 for each coordinate. And then it's this is like some magic. It's like I found it online. So it's basically, if we do it without this part, they will be positioned in like a free space, like which is kind of nice as well.
I mean, probably what this is doing actually, it's moving them away from the center in or something like. It's probably similar to the normal vector stuff we did before. You could do it in a similar way actually. Yeah.
So it's so basically we multiply it, and then we have like a sphere. And here is like what's nice about this is like we kind of control the radius with like with a constant. So if we want to animate this, we add a particle driver outside the loop, so we don't create one particle driver for each particle.
So particle driver is something you called it, right? So it's your variable name. It's there's no such thing as a like.
That's basically a driver like in patches. What is that called? It's a time driver.
Right. So Nolan is asking, you'd have to pull in the audio reactor from patches. Can you show how to patch, bridge, and promise world real quick? So I don't know if that's something people want to see, but that would be interesting. Like if maybe we want to drive our radius with something from the patch.
Yeah,
maybe
let's do a quick example on that. So that would be a value, right?
Yeah.
And let's do like that was radius. Let's do this. Let's get the so we want to control the radius from patches. So then we have to, since we're going to script, right? And it's going to be a number.
Yeah.
Sphere radius. This should be good. Let me just import the patches module. Patches. And this is actually an output from patches now, I think. Let's log this and see. Patches inputs, all inputs for the all outputs, getters.
It's funny.
So-
This is actually way better than the documentation. I use that all the time. Just log a, what do you call it? Not
Yeah.
function, but a module, right?
Yeah, you can log it, but you can log the module you have imported. And there's
Yeah.
also interesting, like I always check it. Let me find it. That one. It's if after every launch of when something is launched, I use this one, get type descriptions.
Okay.
And then you get like all these descriptions, like all of these, and then I compare it to see if something new. And that's how I found out like the new tracking modes, like so you can track moving objects and stuff like that.
Oh, interesting.
Yeah, so that is so it's often it's like a lot. It's documented in the application before it's actually in the documentation.
So can you show that? How do you do that thing you just talked about? Can you just do an example?
Yeah. I think that returns a promise now. That should return a string actually. Descriptions, right? And that is from the diagnostic. Is that the logical diagnostics module? Get type description. I think it's that one has become like a promises.
So you have to do it.
Here it's, do you see? Like, so you, from the diagnostics module, you get type descriptions, and then if you log them, you get like all of it. There's you have to like copy paste this and put it into like a JSON reader.
Right, I see.
And then you will be able to see like new stuff that are added, and like you can create your own documentation like with a better search.
Crazy trick.
They have now.
It's like hacking the patches script.
Yeah, back to patches. Are you still there?
Yeah, we're here.
You're on mute, I think.
No. You should. You guys hear me? Yeah, right.
There you are.
Yeah.
I must hit the wrong button. Yeah, did you get it? Like how you get like all the type descriptions?
Yeah. We saw it. Cool. Thank you.
So now we want to use the radius. That was like the task we were going. We want a radius set from the patch editor. I might need some help here because we're gonna do animation using that to animate as well then.
Well, you can just tie it to whatever face radius or something really quick.
Yeah, so we're gonna do output and what's the new API for that? It's actually here. Let me just find the new, because they haven't updated the documentation on it. There we go, patches module. Get, and it's like a scholar. So since the new API returns like a promise, so we have to wait for it to find it in the project config, right? We have to put this one into promises as well, and we can put it in the same promises. And then what did I spare radius? Let's do this, and that should be the third. Let's see if we get the right value now. This should be a signal, right?
It's an error. It's an error value.
Get Scholar outputs. It looks like it. We didn't log it now. Gets Scholar, and yeah, we haven't linked it yet.
Oh yeah, right.
We need it from here. So now it should log, I think. Yeah, now we get the scalars in a signal.
Great.
So I'm just gonna remove this and then remove this. So since we get a signal, we have to multiply this with a reactive code, right? Because the radius is a signal now. Y set. So if we go in here and update this to 0.5.
Nice. Woo! That nice. Let me do a sound effect.
Bazinga!
Yay!
Yes. So do we have like in patches? Now I want this to animate from 0 to 1 or 0 to 0.5.
Well, you could just do an animation loop.
A loop animation.
Yeah, and then just put the progress into the value. No, you can just directly put it into your value, and then just do mirrored at the bottom, and that's it. Boom! There you go.
Yes. So this is like how you can do animations to this, though.
Yeah, I love it. I love it. Very cool. Yeah.
So like we can trigger this, right? So if we do, you don't have set timeout, but like we can do like a tap to trigger.
Yeah. I mean, in Patches land you can do whatever. Like you can do the same thing in code. Obviously, it's just it was cool to see how you got it into how you got the patches stuff into code, and actually crazy to see that you knew that off the top of your head, because I have to look up that shit every single time. I'm like, oh my god, like I just do it once and then I'm like close the text editor and don't want to have anything to do with it. But yeah, actually I thanks so much for putting that stuff together, because I think we're going to play around a little bit more with code based on your example. It definitely looks fun.
Yeah, like especially like when you can select many objects, and there's so many algorithms for like positioning stuff, and like if you get a lot into it and like you use the time, you can like transition between like formations.
Yeah. It's also super. It's fun because actually this is like a full circle, right? This is exactly the same stuff I showed in the beginning of the stream, so that's really nice.
Yeah, and then we have like we can do like we talked about earlier this week, like doing the return like a promise, not promise, but like a patch signal where you get like the position and stuff like that, right?
Yeah. Yeah, this is actually, guys, this is something real quick at this point. I did a little test for vertex shading again, where I had to do exactly that. I wanted to get the position of an object, and it's like so crazy to me that you cannot just drag the object in the patch editor and get a position output, but you have to go through script. And I put together a little script, that does exactly that. So if you need that, it's on my GitHub also. So this is basically now if I need the position of something, I'm just getting this and I don't have to worry about writing it in code. So that's nice.
Yeah. Let's. I'm just gonna show the driver real quick. Since we have it, I just commented out the patches. I'm gonna leave it in there, and I can write comments on the code. So after it's done looping for everything, this is kind of nice. So if we do like the start and we do like delay it a bit, set timeout, like you can do with like when you start recording, like with patches, you can trigger the animation, right? So it's just like it creates like this amazing, like let's say like wait 3 seconds and then we start the particle driver. We'll create like with this easing, right? And then I get to the point where the reason why I brought in group is like we can also like rotate this nicely now. That you can do with patches as well, right?
Yeah, of course.
Rotation X and do time ms. Let's divide it 1000 and then C. Just change this to 1 second. To create this, we'll do one y-axis as well. Right, and then it comes. Now it's like I have this in the plane tracker now, right? And it's it's playing.
Yeah, so let's talk about plane tracker. What did you find out? What secrets did it reveal to you?
Let's see here. Like, I don't know, does it show like the sharing?
Yeah.
Display. Yeah, perfect.
So this is live, right? This is you doing it right now. This is not a video. This is your phone.
Yeah, this is me.
Very cool.
So what I realized is it's not people are struggling with the plane tracker. It's not like stable enough. Like, let's say it's just they need like a restart thing on here. But because it's always auto starting in let's see. It doesn't get the thing about the plane tracker. It's for Spark to like put it in the world space around you, like the real life, the real reality space, the real world. It needs to kind of like have information like to measure and stuff like that. It's a known problem we call SLAM. It's like what's it called? It's called simultaneous localization and mapping. So it's kind of like when you bring up the camera in Spark on your phone, it starts right away to like look around and like map and like find distances and stuff like that. It looks something like it depends on like what they do, but it's like you can imagine like they put the points and track all the points. And I noticed Spark is always auto starting. You have like this option for the plane tracker to auto start.
Hey, I just want to give a quick shout out to Pandur, who just followed. Amazing. Welcome. Sorry. Good. Hey,
no, so you have like this auto start feature, and the plane tracker starts to track before it seems like it starts to track before Spark has enough information. So I was like looking into different AR implementation. It's like ARKit, like you have like this. If people have used ARKit before, you will get this message. It's now it's in Norwegian, but like it will actually tell you to look around to start.
Yeah, the implementation is really cool.
Yeah, so it's just like Spark. I think Spark gives it too little time, the plane tracker, to like really know its environment. So what I usually do is like I disable the auto start. So if I sync it now, then it should not be like here. Then it doesn't track at all. So we kind of have to trigger that. So let me just. I think this should be possible with the patches as well. Oops. Touch and touch gestures. So to trigger the start of it, we have to do, let's put this earlier. And then on tap, let's do like that. And we need to actually on tap and then subscribe to that event. That should be right. I have the code here. Let's see. And then always I keep forgetting this, so we have to enable the capability. Yeah, I've done that. Perfect. So what we will do, so basically what we do now is like on a tap event, we will try to track that point we tap at. So if I bring it up again now and give Spark more time, let's see if it's focused, more time to like get to know the environment and then press tap. It should be more precise. Now it's like the measurements are like super big. I forgot. Let's see. Are you still there?
Yeah, we're here. But
Yeah.
your window. Oh, yeah, that is.
Let me just make the radius a bit smaller here.
It patches.
Like,
Or did you change it back? Oh, you changed it back. Okay.
Yeah. So it's like because Spark needs more time to get to know like map the environment around you before it starts tracking, or else it will like track to the wrong points from the beginning because it doesn't know enough about your environment around you.
Yeah.
So let me just bring like in. So that what was like one of the findings. So if you want to track plane tracker to behave better, make like what's it called, disabled auto start, and give it like 5 seconds, like let the user look around. There's actually instructions for it, for the user to look around. And I'm just gonna bring in this one as well. It's a bit important. And then it will become a lot better, like when you initialize the start again of the plane tracker. Does that make sense?
Yeah, definitely. It starts looking for planes, and it gets better the more you move around.
Yeah. We can
Actually,
try,
I think what is happening is that first it just uses the gyroscope for like a rough orientation, and then it starts looking for planes.
Yeah, and that is the reason why I know this is like the past weeks I've been working on this, where we actually need the real-world measurements, like to have the measurements to be quite precise. And that's why when I discovered this, like delay it. So like if I now auto start it again, let's see. Do you see it's like totally off and it's jumping around now?
Yeah, exactly.
But if I disable auto start and send it to the phone, now it won't start before I tap, or it actually did. Let's see if it got the right. It still does. Now it's something buggy here. Yeah, now it stopped. So now if I look around this, maybe like the worst location. You see, now it didn't track. But like, give it like a tap opportunity to like make it track better. And then another discovery this week was the sizing of the stuff in a plane tracker. It's super random. So when so I realized, so I was looking, so it looks like when you set a plane tracker, the scale of the plane tracker, it will add it to everything recursively in the tree of the plane tracker instead of just the plane tracker.
I see.
What I did to fix that is, so if you want like consistent scaling, if measurements are right in your environment, you have to take like the now, like you can create like a object you call scalar, but now I like put it on the group inside, since everything is inside a node in my scene.
Yeah.
I set the sizing of that, and I kind of divide it of the plane tracker world size, the scale of it, and then you kind of reverse what Spark does with the trees downwards.
Oh, weird. Okay.
There was a post in the main group about it, and then you can like add scaling gestures. Like if you want, like previously, it's like when you set it, I can actually disable this. It will like the sizing would be super random depending on the phone you were using.
Right. Yeah.
This way, like I got like consistent sizing through. Like on Android and what you call the iOS.
The other guys.
Yeah, I have like a Google Pixel laying around for that. That I'm gonna leave it in the code. Those guys. I have a Google Pixel, so I test everything. Like when I do stuff, I test it on like the iPhone 8 and Google Pixel 2 and. But the phone I have noticed that doesn't have any sense of location is actually Samsung phones. They're terrible.
Oh, interesting.
Like, yeah, so it's so that's what in this thing I'm working on now. That's where we are. Is like we're actually trying to figure out how we can solve it on Samsung phones.
Right. So are you able to share this snippet with a rescaling of the plane tracker stuff so scale is consistent, or is it something you want to keep? Which
no,
is totally
I have
fine.
it. I have it in here.
Oh, code. Great! Oh, that's really cool. So that
so
then basically, if you put this code in, then you can make sure that your scale is consistent in all the phones. And you should be able actually, even if you don't work with scripting, but just with patches, you throw that in, and then it still works, right?
Yeah.
If you do like all the other things in patches.
Yeah, you just need to select the plane tracker and like a group, like a null object inside the first null object inside the plane tracker. Like you need to put that object you want to scale down, right?
Yeah.
So that's basically I like say like based on this plane tracker world size, scale down the stuff inside the plane tracker.
Right. Yeah.
So when the plane tracker is scaled up, I actually scale down the stuff inside it. Right. So yeah, that's I have MSD DF stuff if it's still interesting, but it's like I see it's dragging really long out.
Yeah, I think let's do it. I mean, we can do it on in another time, but basically, I can just maybe show real quick if you what it is. Yeah, just show what it is, I think. Yeah, so basically multi-sign distance fields is like a shader, multi-channel sign distance fields. Is that what it's called? Yeah. I think. So it's a way of like basically rendering shapes with sharp edges. So using your shader. Yeah. So the texture I bring in, I don't know if I have compression on it. So that's like 120 kilobytes and 32 times 32. But look at the sharp edges it gets, like when you scale it up. And the cool thing is that it stays sharp. So basically, this goes back to from my perspective. I made this MSDF shader a while back, actually, here on my Gumroad also, and this is in last October, and then Lasse, you saw it, I think, on the forum or something. So I can just show you a little bit, real quick, the stuff I was doing with it. So it's just some typography stuff, and that goes back to a project Matt from Sting did for, I don't know, for some shoes, and he had typography in it, and he said, yeah, it's a pity that because it's a texture, if you move close, because in AR you can get really, really close to something, it becomes blurry. And then I thought, oh, there was this MSDF thing. Let's see if we can make it that in Spark, and that's what I made. So just like you did show, you can get super close. Oh, look, I had short hair at that point. That's my hair now. And anyway, so you can get super close to the edge of something, and it will stay sharp. So it's great for basically any text rendering or UI rendering where you want resolution independence and stuff like that. And how you do it is you take your original vector file from Illustrator, you run it through a converter, and then you can just use that texture, which you're seeing right now, like the weird color texture, put it into Spark, and get a beautiful, sharp texture out of it. And so this is a hard. And the other good thing about it is that it is pretty small. Yeah. And Noland actually just posted the font converter, which is cool too, I suppose. But this is for whole fonts. So this is like something they do in games a lot. Text rendering with MSDF
actually,
for fonts.
It's a quite common way of rendering text in WebGL now.
As well, yeah. I saw that they use it on the Spotify. They had the Spotify
on Ivor.
Well, I think they use it for everything. They always have the Spotify Best of the Year something, and they do all the text rendering in WebGL and use MSDF. And also
the theory that made.
Yeah. And anyway, so Lasse did the converter, which did not exist before, right?
Yeah, so it's because like the original converter is like you require, like if you want to install it, I think you have like for Windows there's like a already compiled one you can use, right? Install.
And here, actually, if you just want to just scroll down a little bit, and this is a good image to explain SDFs again. So on the right image, you see just a signed distance field with 32 by 32 pixels, and you see it's working. It's better than the middle one, 16 by 16 pixels, but it still has these weird glitches at sharp corners, and that's because an SDF each pixel just knows the distance from the SDF value, so to speak. And on the left side, it's just uses all three channels of an image texture to have the distances for all the axes. That's basically the idea, right? So that gives you the sharp edges that you have like in the A. And it's also funny because you can then use the just fuck with the SDF and do like interesting effects. That's something I found also kind of cool.
You can create like because of the export, like 16 and 16 pixels, and you get like this quality, like almost vector quality, right?
You get vector quality, but you can also do something like that where I'm like here, I'm basically adjusting just some value, I don't even know what, I'm just fucking around with the MSDF texture before feeding it into the MSDF patch, and that gives kind of nice, weird things.
Yeah, and also if you have text, like I don't think the bots will capture like the characters here, like for static text.
What is that?
Like like when you submit a filter, you might get like the static text.
Oh yeah, that's a good one. Oh shit, yeah. Oh wow, this gives us a woo.
Yeah, it's a lot of isn't that what we do?
Yeah, I don't know whether that's true. Whether you can get through. Static text approval with this easier. I don't know.
I think I actually used it in the ASI filter. If I have here we go. then you see like this is the all the characters.
Yeah. I mean, that looks beautiful in its own right. That could be totally the new graphic design style.
Yeah, definitely. But it's a bit tricky. Like you need to install like command line, and if you want to install it on a Unix system, you need to like know how to build a C program. I've been talking about it, but it kind of like and it's kind of stopped up like the hype about the MSDF, right?
Yeah.
There's like the process of making it kind of stopped up, but like this is like work in progress. So here is like I'm making this online graphic interface tool, and this for people can easily like take any shape. Like so, this is like a heart shape I have, and something you have to notice like it only works with one path. So if you have a SVG with many paths, it doesn't work. You have to like make them into a compound path for them to work.
Also, if you're interested in this, and this obviously, I mean, this shade I did, this is something you can also build yourself. There's documentation online for how to do that, and I just also Googled it and then I rebuilt it in Spark, right? But like, if you want to get that asset from my Gumroot, it does include, basically a little manual where it says. Yes, it's Gumroad. Yeah, I don't know if you're going to send it. I'm just going to post it in the chat. But basically, it includes a little how to prepare your vector files, and it does need a little bit of trial and error sometimes. I noticed.
So that is something I'm working on this tool I'm building. So this is like you can just drag in a SVG. And you will get the preview. I haven't hooked on the sliders yet because like there's some adjustments you can do. Is if you see it working poorly, you can change the pixel range and like stuff like that. So it's actually live, like the current state of it, but it's like has no information and stuff like that. So you can actually like upload a SVG path and like download it.
That's amazing. Especially I like the copywriting on your text there. This is some good quality.
Yeah. It's a part of like this algorithm. It's So it's I'm doing some. Actually, I'm commissioned to do some type experiments in Spark. So I'm gonna do like multi-sign distance fields to create some kinetic type. So definitely gonna use multi-sign distance field.
Really cool. So that's amazing. So thanks so much for that, Lasse. And I'm gonna put all the links and everything in the Discord. So if you want to, like, after the stream, thanks for the link. I'm gonna copy it into Discord because the Twitch chat, I think, is, I don't know if you can you replay it after the stream is over? I'm not exactly sure, but anyway, you have those two links, and with those two links you can make amazing, super sharp vector shit. Yeah!
Yes, and I sent the links in there.
I'm sorry. People can't hear you over my stupid sound effects. Come again?
Well, I don't hear the sound effects. I've been where's the sound effects tonight? It's because I muted Twitch TV, so I've been confused. But I shared like an answer from the guy that made like the MSDF generator. If people are like more interested in like the data science part of it, it's he wrote a master thesis on it. So.
Yeah, exactly. He did it in his master thesis. I noticed that too. Pretty cool. Really nice idea.
Yeah, and I dumped the link for the staging, like for the generator, like so people can try it out. But there's like the only thing that's working now is like dropping SVG and downloading it.
Right, but I mean, if you're gonna work on a project using that, maybe you update it. Yeah. So I think that was totally worth it, right? That wasn't like, I think that was really cool. And I love playing around with that stuff because really it makes some really cool, interesting things possible. You can do text deformation also, right? Where you can just warp the stuff, but you always have super crisp angles. So
yeah. If you like figure a way to export SVGs from After Effects, you can like do like super neat animations.
Oh, that is an amazing idea. Oh, that is so cool. Okay, so you're gonna take an SVG from any After Effects. Or actually, you know what? You can use. There's this thing. Oh, this is really cool. So there's this program called Loom. It's by this amazing designer, and he also does iPhone stuff. I'm just gonna paste it here also in the chat, or just show you here on stream actually. So it's just this is something that's really cool too. So you can make little loops and just draw them on your iPad, and it's by this guy Elal. I always mangle his name. I'm sorry. I'm unfortunately bored. Let's see. Here, Eran Hileli. He's like amazing, amazing designer, and I suppose Finn Eriksson's probably the developer. And what you could do is you have just an SVG animation where each frame is represented by an SVG. Take this, run them through Lasse's converter, put them into a texture packer, and do like a sprite sheet out of it. Run the animation, put them through the MSDF patch. And then you would have animated, crisp, super sharp. Hey Joshua, thanks for the follow, Josh. I'm gonna make sure to check out your channel also. Like I said in this chat, I'm still new to the whole Twitch thing, but interesting world. So yeah. Anyway, basically using it with animation is an amazing idea. Really cool.
Yeah, like how many animations can you have? Like how many frames can you do then? Because like if like we say, should we say 800 like 16 times 16 in MSDF? Like that's like 800 frames.
Tom Pandu is just asking, is there multicolor output for MSDFs? Well, I mean, what you could do is you can just, because it's essentially vector, you can layer them, right? You can do like, I don't know, do one line art in one MSDF and then the next one in another one, and then recreate the shader. Actually, I just want to give another shout out to Pandu here in the chat, Pandur. And he's a creator of a fucking amazing tool for any creative developer or anyone interested remotely in what we are doing. Definitely check out his stuff. And he did this tool called Cables, and I think a lot of people here on the chat already know that. But like this is essentially like patches, but for WebGL, and it's like the most amazing thing ever. And unfortunately, because I'm always have my head so deep into Spark, I'm not as good in cables as I want to be. But anyway, this is the best ever. Like if you're at all interested in creative coding or anything like that, check this thing out. And I recommend it to everyone. And it's also super easy to learn. Like a friend of mine, he just got into it, and he has no coding background, and he got into it like super quickly. And I just learned also do a Twitch, so check out their Twitch.
Yeah, and like Cables, you also get like the code, if I remember right. You get like the code on it, so you can like learn from it.
Yeah, exactly. It outputs JavaScript. So this is actually doing exactly what we are thinking that Spark is doing as well. So the nodes are wrappers around JavaScript. And Tom, Pandu, correct me if I'm wrong. Also, funny thing, Pandu he's also from the demo scene. Like the first little thing I showed you guys with the, with the sign thing. This is something from a demo I did ages ago. He says a similar background. Yeah. Cool.
There's a question about web VR or web AR. It's the problem there is like it's not many browsers supporting it.
I think not many browsers are supporting it. You're saying?
Yeah, not many. It's like the AR and VR in JavaScript on web in browsers, web-based AR and VR.
Yeah.
It's there's actually they're working on a specification for those APIs.
Right.
It used to be called the Web VR, but they have changed it to Web XR now.
Right, I see. Yeah.
It's like it's experimental and it's like very raw. So currently, if you want to do VR or AR in that, you need to use like third-party libraries that's not using the API that's from the specification.
Yeah, I mean, I think it's a pity that the web, or generally speaking, the data space, if you want to call it that, cyberspace, I don't know, is so fragmented that you have all those little kind of like spaces where things happen, and I think it's really a pity that it diverges so much from this original idea that you have like you have open standards, and now people are basically reinventing the wheel all the time, but it is what it is. I don't know, but anyway, WebGL is definitely totally cool because it just runs anywhere, right? Like you just need a browser and it works. And web AR maybe not yet, but definitely good stuff.
Yeah, and that's what's nice about Spark. Like I've been doing AR apps and VR apps in like natively, but people don't use it because they have to fucking download that.
Yeah, no one downloads anything. That's the thing.
It's accessible at the time, and the same with Spark AR is like people have Instagram and Facebook to use it.
Yeah, definitely. All right, cool. Well, I think we did this. I thought, in the beginning I thought, oh, this is going to be short stream because we had so much pace going on, and now it turned out to be quite long. And I think I would want to first of all thank you so much, Lasse, for doing all that. It's really amazing. And I think it's really cool to have such a community. That's really what makes Spark a lot of fun. And so guys, like if collectivized Facebook, I would be totally up for it. Yeah, it's weird though, right? Because there are alternatives and people are not using them. Like this Elo thing or whatever that was called. But yeah, guys, in the chat, like if you have any questions for Lasse or for myself, then maybe now is a good time to ask them.
Yeah, ask now, or like if you have a question, post in the community. It's like the nice thing about posting in the main group instead of writing directly is everyone gets to see like answers and like get to learn something, right?
Yeah. Well, I mean, the main group, the thing is like for me, and I guess like people agree, is that it used to be really, really nice when it was smaller. And I mean, this is totally weird hipster bullshit to say that I liked it before it was cool or whatever, but it really was. And now like everyone's just asking, how do I do, I don't know, the simplest thing. And I mean, obviously everyone needs to learn and it's totally fine, but it's so weird. People only care about like how many views something gets or how to position themselves on Instagram and stuff like that. And David asked, what product do you use on your hair?
This is how I'm born.
It's called not showering and quarantine. That's what I use anyway.
I was thinking today, it's like I wanted to make like this your haircut like in a 3D and like a nose ring. So when you saw me today, I would be like,
yeah, I can actually, I have this thing. It should work. Just let me just try something real quick. I can be a cucumber. See. Well, I'm here. Yeah, see. Oh, hello. I'm a thinking cucumber. I have this stupid Snapchat filter still thing installed. I wish I had that for Spark. Actually, that's kind of cool. You can run your webcam through.
It's like Snapchat has that. They have like
yeah, that's what I'm using. Like if you look at my me right now.
If someone from the Facebook is watching. Looking at you, Zach.
Yeah, we did ask, but there was no one watching.
Yeah, this is you should learn from. It's like in Norway, Snapchat is super big still.
So Mark Wakefield, hi, is asking whether Vertex shader stuff pulled me back in. Actually, Twitch did pull me back in because I kind of got interested in I just was just basically bored and surfing around, and I found those Twitch streamers and I found it interesting, and then I was like, well, what can I stream about? I was like, well, why not Spark? And then I posted this that was my first Facebook post in months. Posted that question whether people wanted Twitch or what, and that put me back in. And then actually seeing doing the preparation for the first stream last week, I looked a little bit into Vertex shader, and that totally fucking put me back in. This is so much cool shit. Like if you follow in the main group and just search for Vertex shader, I've been posting, I don't know, 3 videos an hour or something.
Yeah, it's I noticed Nolan mentioned like the Spark AR community on GitHub. I'm definitely gonna push the code here today.
Oh yeah, that is interesting. Nolan, can you maybe send the link again so I can put it in the? I don't even know where that is.
Let's see. So it's currently it's
there you go.
It's 4 people that has access to it now. It's like that can maintain it. It's like Josh and Nolan and Luke and I. So we have shared some juicy stuff there. It's like, but if I see something useful being posted in like scripting and stuff like that in the main group, I will put it into the Spark AR snippets and like keep that updated.
Yeah. That's really cool. And also, guys, you can join the Discord if you want to have like just another digital outlet for. if it's not enough to be on Facebook, on Twitch, and on GitHub, and on I don't know, where else you hang around. Then you can
Slack.
also
someone on Slack.
go on this. Oh, and Slack. Yeah, I don't like Slack, but
the Spark AR newsletter. Do we have like a community?
Hey, Josh, you're saying shader showdowns. Well, what shader showdowns? Fill me in. Where's the link? I get to, Also, guys, I saw you can rate other channels. So we need we want to. Oh, a phone call. Yeah, let's do that. A phone call with 100 people. So I want to rate some channel. So anyone has a good channel we want to rate, just post it in the chat. Otherwise, I have an idea. Oh, revision. Oh, this is yeah, man. This is of course. This is also something. If it's the same thing, that's a demo party, right? Yeah, Tom is also taking part in that, right? Pandur, you're part of the revision community, right? Are you still on, Tom? Well, maybe not, but yeah. Oh yeah, very nice. I'm gonna follow this right away. GLS. I mean, anyway, Shader Toy, right? Shader Toy all day long. So which channel should we rate now? I don't even know if that works, but I want to try. Or if you have more questions or whatever, that's cool too.
Yeah.
Okay, so I'm going to try to rate this channel here. This is also creative coding, and it's about 3D and creative coding. I found the guy the other day. I don't know him personally. It's called So Much Monsters. And I just read that this rating, I have to just put rate and then the channel name in the chat. Let's see if that works. Maybe it doesn't even work. Rate channel, yeah, that'll work. And it's apparently a good form to say something to them. So I don't know, just say hi or whatever. Rate? No, not rate, but like, oh, hold on. With your MSDF side, I just tried and it doesn't work for me. Well, Nolan, actually, you have to fiddle around. With that a little bit. This is something I noticed for the terminal, like the command line version of it as well. It can't, like, for example, if you have an SVG RAID, exactly RAID. Like we're rating a channel, but just for the SVG stuff, you do have to fiddle around with that a little bit. For example, if you have an SVG where your path is inside of a group, nested in groups, it doesn't work. So it just needs to be it's just one path without anything else. So you do have to maybe even go into it and like Vikings, exactly. You do have to maybe even go into it and edit the XML. Yeah. So play around with it a little bit. Eventually, it will work.
Yeah, it's the key is like the SVG should just contain like one path.
Exactly, and nothing else. I noticed that again, like when I had it in Illustrator, I did like I forgot what it's called, but again, it's in the description of the patch. If you download it, it's described how you have to prepare it exactly.
Yeah, I'm gonna write that actually as a note, because there's actually libraries I can use to merge together all the paths, and like so we end up like I can fix that.
Oh, that is really cool. What is this? What's going on, Nolan? Oh my God, you're hacking the chat.
He's using CSS.
Don't click on it. It's the virus.
Excellent. That's quite fun with SVGs. It's like super unsecure format. It's like you can hack websites and stuff like that.
Oh, actually, guys, by the way, did you hear about the exploit with the Apple Mail? I just read about it. It's crazy. Like on the latest iOS, there's apparently a vulnerability in the Mail client, which has, I don't know, how far it goes, but basically it opens up your system even if you don't click on the attachment. You just have to basically get the mail and you're fucked. So just don't use iPhones.
Don't use mail. I still use fax.
Exactly. Yeah, very good. All right, cool. Guys, that was fun. Let me do another little audio with here. Okay, what do we do?
I don't hear the sound effects. It's just like...
Really? That's how they got a celebrity news? Oh my God. Cool. So it's called a day, I think. Although it's fun to just hang out and whatever. But we can do that on next Sunday again. Let's see what we're going to talk about then. More vertex displacement, more promises. I don't know.
She was the one that said not to do stream as well.
Who's that?
Omi. It's like,
Oh, yeah, that's true. Yeah, Omi, you nominated yourself to be on the stream, and Lasse already made it happen. And Motorrad Breakdown, yeah, another time maybe, yeah. And also, Omi, I would really love to get a little bit of insight in how your thought process works, or I mean, I don't know what you want to present. Again, like, oh, yeah, we did not do the pole dancing in the end, did we?
I think I have to go now.
Yeah, it's about time. Yeah, and Aaron. Yeah, I mean, we have so many talented people that we can chat with. And actually, we can also do a stream maybe where we don't do any coding or anything and just hang out, and maybe we can also get more than just one guest in and just, whatever, get 3-4 guests in and talk shit.
Yeah, and I think it's like a big, people have like common interests in this community. So it's like nice to like gather people, and like you don't necessarily just have to talk about Spark, right?
Yeah. Absolutely. All right, whatever. You guys think about what you want to do and then let us know. Yeah, Omi, you're on. You hear it. Oh, talk about Notch. Yeah, Notch is actually... Josh, have you been doing a lot of things in Notch? Notch is kind of also super interesting and something I wanted to look into as well after I look into cables. Yeah, it's also from the demo scene, the Notch. So Josh is talking about Notch 1, which is also a node-based real-time graphics application for, if you don't know, I'm just going to show it to you. And it's basically a competitor for Touch Designer in a way, right? Oh, there you go. Thank you, Nolan. Too quick. And it's cool because it runs on those servers and computers they use for live visuals. So there you go. It runs on media servers. So basically there are those for big concerts and stuff like that. There are those few media servers all the companies use. And it's basically impossible to do anything else then use those media servers. So the idea of Notch basically was to kind of like hook into those media servers, because then you can use it at big events. And it's also a node-based tool with amazing capabilities. It's crazy what they can do with it. It's like basically Unreal Engine but for visuals, if you want to look at it that way. They have like the latest GPU stuff, and they have like global illumination, like real-time global illumination, and they have like all the hot shit is in there basically. And yeah, so this is definitely cool too. Notch is crazy for events, yeah. But Josh, yeah, definitely. Like, if you want to be on the stream, how about doing it? Actually, I saw you hosting this quarantine thing. That was one of the channels I looked at when I started Twitch. I think that's actually the thing that got me into Twitch. Somewhere I saw it, and then I was, oh my god, Joshua Davis, he's everywhere. Yeah, cool. Yeah, this is also definitely. But the thing is, you can't do everything, right? It's kind of crazy. I don't know how you can't. If you look into all the different things, you're never gonna get deep enough to be able to actually make interesting things in one platform. At the same time, it is valuable to learn the basics. This is something I have to think about with Spark a lot, because it so reminds me of Flash and of kind of like the old school things I've been doing like when I was a kid basically. And then I thought, hey, this is never gonna be of any use. Like if I learned how to draw bitmap fonts, for example, what I did like back in the day, like I don't know, on C64 or whatever, like on Atari or I don't know, and it always comes back in waves, right? Then you have the mobile phones, Nokia and shit. Then you had display displays with very low density again, and so on. So yeah, anything you learn is valuable. So
exactly. I'm gonna hang up now. I'm gonna take some time and write some comments in the code and share it.
Yeah, very cool. Very cool.
I'll send it to you so you can add it to in the Dropbox. And I'll also publish it on GitHub.
Great. So guys, this was fun. We're gonna rate so much monsters, and then we're gonna say I don't know. I never did a raid before. We will see how it goes. So I'm just gonna type this command in the chat, and then if you want to keep talking, just maybe do it on the Discord. I don't know. All right. Let's see. All right. Bye-bye. Let's see what happens if I put the command. I think there's a countdown or something.
I'm not leaving into live stream.
Oh, this channel has follow or subscriber only chat. Oh, okay, it doesn't work. Fuck. So we have to look for another one. I have another one. This guy is also really cool. He's like a 3D. What the fuck? He's cooking. He's like a 3D modeler. But yeah, he's cool. And he's like a 3D modeler from ILM. But he's cooking.
Oh.
All right. See, so he's doing 3D modeling and cooking. Okay. If anyone has a good channel that's online now, we can raid. Just gonna wait a bit to see.
Yeah, with 29 raiders. Okay, yeah, I'm gonna hang up. Thank you.
That's
guys.
it. Take care. That was fun.
Ask if you have any questions, and I'll do my best to try to explain it.
Cool. All right. See you in the group. Bye bye.
See you.
Bye bye. Oh, Joni, what have we done? Thanks, Lasse. That was amazing. That was really cool. Okay, so I'm gonna see if that raid this works. No, it doesn't work either. Oh my god. Okay, how about this guy? So he's playing pixel games. I want to know whether that works. Okay. You already have a raid in progress. Yeah. I guess Julian would be of help, but I think he said he's off. Yeah, so I have to probably watch a YouTube tutorial to do raids. The raid is working? Oh yeah? Oh, right now. Okay, so we're gonna look at some cooking, guys. I don't know. Say hi from the Spark community to the 3D world, 3D modeling world, cooking world. Okay, bye bye. Next Sunday.
modeling. Yo, so for people who don't know,